All right, welcome back to Chapter 4. We're going to stay in Section 4.2, talk about multiplying matrices. First thing we're going to talk about, just some properties of matrix multiplication. We talked about some of them a little bit in the last video, but in this one, we're really going to talk about a couple different ones that we can do. We've talked about these with most of these with real numbers. Now we're just going to apply them to matrix operations, matrix multiplication, like we did with addition and subtraction. So the first one, first of all, capital A, B, and C are matrices, and C is going to just be a scalar. Remember that scalar is just that number out front. So the associative, if you're multiplying matrices A, B, and C, it doesn't matter where you put your parentheses. You can do A and then BC in parentheses, or AB in parentheses, and then C. You're going to end up multiplying all of them together anyway. Then, the left distributive property. As you guys saw in the last video, the order in which we multiply matters. With real numbers, you've got that commutative property where if 4 times 3 is 3 times 4. But with matrices, at the end of the last video there, we saw that that doesn't hold with matrix multiplication. It's a little different. So, but we do have what's called the left distributive property. So if A and then B plus C is in parentheses, so that A is to the left, then when we distribute, A will stay on the left. So you're going to get matrix A times matrix B plus matrix A times matrix C. Same thing with the right distributive property. So if I'm distributing from the right, matrix C, then I'm going to keep matrix C on the right. So A times C plus B times C is going to be that. And then I've got the associative property of scalar multiplication. It doesn't matter if I multiply my matrices first, if I multiply matrix A by that scalar first and then multiply it by B, or multiply matrix B by that scalar and then multiply that by A. But what we did see in the last video is that if I am multiplying matrix A and matrix B, that is not equal to matrix B times matrix A. If it does, if those two are equal, then that is going to be a special case, so that'll be the exception to the rule. And just refresher on scalars, I'm sure you guys have forgotten those a little bit since we talked about those. So if I've just got a little 2x2 matrix, I'm just going to make up some numbers, 2, 4, 6, and 8. I know, keeping it real original. If I were to multiply this by 3, that 3 right there, this is my scalar. So just refresher, since we were talking about scalars and all that matrix multiplication. So don't forget, you can just multiply by that scalar value like we did in section 1. Then one cool thing we can do with matrices is we can make what's called an inventory matrix. So the inventory matrix is basically what you want. Then we're going to talk about how much each item cost, and we'll put that into another matrix, and that's going to give you your total cost matrix. Yes, I know that you could, calculate this all out one by one, and it'd get you there, but here's just a little different way. I think it's a little cooler way to do it. And again, notice with our matrix multiplication, my ends are the same, so those middle numbers are the same, and the final dimensions that I get for my total cost are going to be my outside numbers. It's going to be an M by P matrix. So the real key here is, you guys are probably going, what are we going to see with these? What are they going to look like? So nice simplified matrix for nice simplified example for us, where we've got 2 softball teams. We've got a women's team and a men's team. they need equipment for the season. So they tell you that the women's team needs 12 bats, 45 balls, 15 uniforms, and the men's team needs 15 bats, 38 balls, and 17 uniforms. Some additional information that we give you is that each bat costs $21, each ball costs $4, each uniform costs $30. Then we're going to use matrix multiplication to find the total cost of all the equipment. So now I have to be careful on how I set this up. So since I have 3 categories of things that I need, and I've got 3 prices. I'm going to set this up so that my cost matrix, coming back from this slide here, that cost matrix is going to be just a column matrix. So to do that, I have to pick how I set up my equipment inventory matrix. So to do this, I'm going to need my women's team as a row. And I'm going to use my men's team. Oh, men's, if I can spell. And I need my bat, ball, and uniforms. Then the women's team, they tell me, needs 12 bats, 45 balls, 15 uniforms. Men's team needs 15 bats, 38 balls, and 17 uniforms. Again, put some brackets around here. We've got our matrix. And we've got our cost matrix. We're going to multiply these two. And each ball is going to cost $4. Oh, each bat is going to be $21. The ball is going to cost $4. And the uniforms are $30. Now, just to double check that we've set this up correctly, because if we don't set this up correctly, it's not going to be possible. So we've got a 2x3 matrix here for my equipment, and I have a 3x1 matrix here, and we did it correctly because these 3's in the middle are the same, and we should end up with a 2x1 matrix at the end. Now, just like before, we're going to slide this column matrix of 21, 4, and 30 up over the top. So 21, 4, and 30. And I multiply away down my column. So my new matrix is going to end up with 12 times 21 and 15 times 21. I'm going to add on to that 45 times 4 and 38 times 4. Add on to that 15 times 30 and 17 times 30. So the reason that I wanted to set these up, I know my columns in my inventory matrix, what everybody wants with the bats, the balls, and the uniforms. I know those were columns, and I set up my cost for each as a row. But as you can see, I end up multiplying my cost of the bats goes down that column. So that's why I wanted to set that up as a column. So a little different. You could end up doing this with if you switch men's and women's up top, and you would have to make this a row matrix for your cost, but this is the way I like it a little better. Makes it a little easier for me. So, then, if I multiply and add this out, 12 times 21 plus 45 times 4 plus 15 times 30. You guys can all punch that into your calculator. That's going to give me 887. And 15 times 21 plus 38 times 4 plus 17 times 30 is going to give me 997. So that's a nice organizational way to see how much the entire season is going to cost for these two teams in one setting. So the women's is going to cost $888 for all the equipment that they need. The men's is going to cost $997 for all the equipment that they need. All right, that's all I have for you today. So if you have questions, let me know. Again, we'll work on this in class. Thanks for watching, and I will see you in the next video.